right, welcome back from break. Hopefully everybody had a good lunch, good break session. Next up is Ariel Shuper of Cisco, who will be going over Kubernetes Security and PSP deprecation. But prior to that, I want to announce our silver sponsor for this session is IAM Pulse. So if you've ever struggled with an IAM policy and thought, how did I get here? You're not alone. So IAM Pulse is a new community focused on helping folks wrangle those pesky policies. And also, just a quick reminder to post questions in Slack. We will cover those throughout the session and at the end of the session. Thank you. Over to you, Ariel.
Thank you very much, and hello, everyone. I wish I could be there in person as well, but due to the COVID restrictions, I'm staying here in Israel, in Tel Aviv. So, hello, everyone, and let's talk about Kubernetes security. The main idea or the main reason for this talk is based on the recent deprecation of PSP. PSP was deprecated in Kubernetes version 1.21. There's a new model which was released or presented in version 1.22. It's still work in progress. And so it's going to be a good opportunity to discuss the security context, what we can do in Kubernetes, and how powerful this utility can be. So that's about the topic of today. We'll talk about different aspects. Let's first start with who am I? So, as I said, my name is Ariel Shuper. I work today in Cisco. I'm a product manager in Cisco Emerging Technology Innovation Business Unit. Prior, I joined Cisco following the acquisition of Portshift. In Portshift, we worked a lot in cloud-native security tools, worked a lot with PSP, with Service Mesh, in order to create natively integrated security tools for Kubernetes. Before joining Portshift, I worked at Aqua Security. I was the head of the serverless security there. And prior to that, spent some time in Checkpoint. Doing some contribution to the community, working on QB, runtime vulnerability scanning for Kubernetes. I did some work in the Istio security working group in customized identities. Contributed to the MITRE attack metrics for containers, and doing today some work in CNCF initiatives over serverless security. So just before we start, let's just a quick background. Pod security basics, okay? What do we need and why we are at? So now, pods are the basic Unix construction in Kubernetes, right? And pod has a security context. Security context control the runtime security configuration of the pod. Now, those settings are very powerful. They can really provide tremendous protection and can eliminate a lot of the tools that are being used today by third parties, but they have to be used carefully, okay? Because if they're not used carefully, they can enlarge the attack surface. If they're not managed, if they're left with the default settings, they can open big doors. And this is why, like any powerful tool, you need to know how to use it. Now, pod security policies, or PSP, were designed to control the security context. So there's a policy that can define how the security context should be set, and pods that pass those policies can run. Otherwise, the pod will be rejected. So this is just a basic to see where we are. Now, let's take a look at an example. Okay, and I just took it from AWS from KS. So on the left side of the screen, we have the policy. This is where we define the security context of the pod. So take a look, for example, at the spec. So you can see that in this case, this is a very permissive policy. The pods can run privileged, okay? Not a good security best practice in Kubernetes. Privilege escalation is allowed, okay, it's true, it's allowed. It has all the capabilities that inherit from the operating system. It can mount any volume, even the host path volumes. It can use the host network, the host ports, the host PID. So pretty much, if a container which is protected by this policy is being breached, the rest of the work for the attacker is really, really fairly easy. Now, in order to make this pod policy effective, there are two more steps that we need to do. We need to create a cluster role, okay? In the cluster role from API group policy, we need to add the verb use, so we allow to use this policy, and we need to make a binding of this role. So not just role binding, and then bind it to like a service account, which is typically the case, or a user or a group, So this way you can apply it on the desired environment. Now, to better understand the context of it or where it falls, I brought in the MITRE attack matrix for containers. Now, there's a dedicated session later by Jen Burns, probably going to be much more interesting, so I'm not going to dig a lot about it. Just I want to, to draw the map, where the pod security context fall in. So if you look at this attack, which show the different stages of an attack on containers, if you're doing good pod security policies, you can eliminate the privilege escalation, you can eliminate the credential access, the discovery, the impact. So you can really use a good portion of your security work with good security policies. You can that can be used by themselves. They probably need a complementing solution, but they can take a good part of your security posture in your cluster if you configure them correctly. So if everything is good, why PSP is deprecated, right? If they're so powerful, why website deprecated? So the reason for the deprecation is really that in practice they are very, very hard to use. So there are issues like when you add a PSP to a running cluster, but you didn't configure the policy, then the default will be to deny any pods entry into the cluster, which that's a bad result. The auditing functionality was not great. So if something happened, it's very hard to track it. Today, I spent some time with one of our users trying to identify what's the problem, and then only finally realized that there is a PSP that someone defined. He was not aware of it, and it was denying the operational work. It was very, very hard to understand or to see the results in runtime. And also, the structure that you need to create a resource, then you do the role binding, and just create a resource, doesn't do anything. If you don't do the role binding, can sometimes miss, and some corner cases of large deployments or that have multiple service accounts, or if you have replica sets, and sometimes can be overseen, and the result will be a bad result. And consequently, of course, PSP is deprecated, and Runtime is going to finally removed in 1.25. So if PSP is deprecated, what can you use? And the good thing there is a new security model, and I think this is much better and much simpler and easier to use. And the new model is defining standards, which is just like, the policies that we saw. They define the isolation, the hardening level, of the pod. They restrict the usage, they restrict, the different restrictions. And we have an admission controller. Admission controller is a significant improvement, significant change to the previous model. And this is where we enforce security. So we have a policy defined, and we have the enforcement by an admission controller, and both together create for us a new model. Yeah, great. So now we have a great model, and let's talk about some of the details and examine those details. So Kubernetes also defines security standards, default standards people can use and implement, and just out of the box. There are those standards are 3 different policies that cover the spectrum. The policies here are cumulative, so they start from highly permissive to highly restrictive. So the first one is privilege, which is completely unrestricted. You can do anything, doesn't change anything. The baseline, focusing on privilege escalation, so I want to minimize the context of the pod. And the restricted, which I think it's a bit worried, because nobody wants to be restricted, but it's really, I would define the security best practices really set up, a good security posture for the cluster. Talk a little bit more into the details. So the baseline, is focusing on privilege escalation. So you cannot mount host namespace, and you can't run as a privileged container, and capabilities are minimized, and the host path volumes are restricted, and host ports are restricted, and you can use up Armor as a Linux, right? But this is, a good way forward. And the restricted, which I think is maybe a better word, is also preventing, some limit only the volume which you can mount. So there are certain volumes completely are not in the scope, and eliminate all the the root capabilities. So you must run as non-root. You cannot use root groups, etc. So maybe the word is not great, but I think it's a great way forward to get good security posture for Kubernetes. Now the admission controller, and this is I think the interesting part here. The admission controller is really a very powerful tool. So there are two admission controllers. There are the mutating webhook that allow us to modify objects. So admission controller is intercept the API request from going to the API server, and peer authentication of the object. You can verify certain things, right? So there is the mutating admission control. They can modify the object based on the policy which is desired, and there is the validation. Validation just validate that it meets the conditions or meets the policies. If it's not, it's rejected. Admission controller can be validating, mutating, or both. And the admission controller works in two phases. So as you can see in this drawing that I brought here on top, you can see the different phases of an API request. And there is a phase we get the mutating admission, and there is the validating admission, right? And first we have the mutating, and then right after comes the validating. So why is it important? Because if you really want to verify that what mutating did was not changed down in the process, you need to do it together with the validating. And the way it works that if any of the controllers reject a request, the entire cycle is rejected. And in our case, if any of the pods is rejected by the admission controller, it will not be deployed in the cluster. Now, if you look at the current model that is proposed now in Kubernetes, there are a few challenges but before talking about the challenges, let's first admit that it's a great initiative. It can really accelerate the adoption of security hardening best practices, and I think it's a great way forward. And it's much simpler to use, right? But if we do want to kind of look at it and examine it, there are two challenges in this mode. One challenge, in my opinion, and since it's not a live talk, I would love to hear your feedback in Slack or in the feedback form. I'd love to hear what you think about it. Is it only uses the validating webhook. Validating webhook means that if it doesn't meet the policy, it will fail. Now, what is the practical meaning? Someone need to go back and do this another rotation and make the configuration changes and change security context and make the deployment again. So sometimes, due to different structure, organization, and different responsibility, you don't want to reject. You want also to fix it. If there's an issue, there is a certain policy defined, so fix it, right? Not just tell it, because a lot of times, not every time it's intentional. Sometimes it's just mistake. I just have the default setting. So this is one challenge that I have with the current structure that is only allowing the validating webhook. Another challenge that I see here in the model is the fact that the granularity, at least from what I see, is only for a service account. Only for a namespace. So if in the previous PSP model we were restricted to a service account, now it's in a namespace. Now, namespace can have multiple services. Okay, you can have lots of different services. Many times people just use the default namespace, and that means that you can really have one policy per namespace. And not all pods created equal. Not all pods has the same risks. Not all pods are exposed the same way or access the same resources. And it's not like one size fits all. Sometimes it makes sense to do more granular and to give you more ability to play with the policies and create different policies for different pods. And the proposed model that I would like to suggest here is to use both the mutating webhook and the validating webhook, to use a hybrid admission control. And the mutating admission control will fix the security context based on the desired policy. So if it can eliminate a lot of mistakes and a lot of unintentional mistakes, leaving things as they are. And the validating webhook will also be used, but it will verify that there is, since it can be different mutation on the way, that no one changed the final setting. So the final setting will be applied. But the good thing is that at least all the pods which come into the validation phase needs to pass the mutating webhook. This is one thing which I think can really simplify, save time, simplify the usage of this model, and can solve some knowledge gap. Different people manage different things. Another important aspect, I think, is the granular implementation. We want to have the ability to apply it per pod. So per pod or group of pods, or we can define if it's labels or SPC if you want to be a more, granularity, to have a mean to identify pods and to apply this based on these attributes, the policy on those pods. So we can really have a very granular security policies per the risk which the pods impose, not have one size fits all. So those are the two suggestions I want to share. And in order to examine how those suggestions can be made, let's take a look at the last part of our work and the policies. And in order to look at this, we have policy engines, right? And one thing that in Cisco, we faced is the fact that people said, we want like a friendly policy. You want something which is declarative. I can give developers to that. I can let developers own it and they can do it together, because security team cannot by themselves define it for every application. Developers know it best. And in Kubernetes, we have a good, well-defined concept of policies. And in CNCF, two good projects working on policy engine. One is OPA and one is Kiverno. And both of them can be used in order to simplify and let developers define the model that we just discussed. And just quickly go over it, and by no means I'm not an expert in it. I saw some other more detailed sessions, at least on OPA. So OPA is a lightweighted general purpose policy engine, okay? The policy is written in Regu, which is declarative language, and it's a very powerful way to describe your policy. So other than you need to learn a new scripting language, there is, a very good way to create different, complex policies. And, in the you can see on the right-hand side an example of a Regu-based policy for pod security standards for the privilege mode. Now, from CNCF, stats, it's a graduated project, it's 4 years old, 5,500 stars for OPA and 2,000 stars for Gatekeeper. And Gatekeeper is a complementing piece. It's an admission controller, which was built to enforce Regu-based policies in Kubernetes. Now, the competing project is Kiverno, and Kiverno is, again, another open source project. You can validate, mutate, but OPA as well can do the same. You can validate, mutate configuration. So if we want to use validating and mutating, both OPA and Kiverno are good candidates for that. Now, the good thing about Kiverno is that the policies are Kubernetes resources. So you can see on the right-hand side of the screen, they're just like any YAML file, any CRD, easy to define, easy to use. It's, 2-year-old project, still in sandbox. GitHub stars, I think 1,300 last time I checked. But I think it's a very interesting approach. Now, again, without taking any sides, which one is the best? Each one has its pros and cons. So OPA is a lot of capabilities, can do very complex policies. You can really, it's a very powerful tool, very established communities, has lots of use cases. Now, the only caveat I see here is the programming languages. Not everybody loves to use the Regu, not everybody loves to use it. So this is the challenge. I saw some challenges about the mutation building. I didn't experience personally, but I saw some writing out about it, about the mutating capabilities. Now, in Kiverno, the advantages, of course, are the simplicity of policy expression. So it's very easy, just native in Kubernetes. It's very, very easy to use. Mutation capabilities are solid. But the drawbacks are that, again, it's YAML. It's hard to do complex policies, not possible. And it's still young and early stage. But I think, in my humble opinion, it's more friendly for Kubernetes, users. And like I said, in Cisco, we took this approach when we created our policy engine for Kubernetes. So just to summarize, I think I'm running out of time. No, sorry, wrong way. Just to summarize, hardening pod security runtime configuration has new and friendlier model. Pod security standards and admission controller replace the PSP and the RBAC. I think we can do with some small twist, we can make it even more secure. And declarative policy engines are probably the right tool to do so. There are different great tools that offer modification. You can use them to get this more secure model. So thank you very much. I hope this session was useful. Feedback is always welcome. There's a feedback forum, and you can just, shoot me a message in Slack or in feedback. Thank you very much.
Thank you, Ariel. And are there any questions from the audience? I don't see any questions at this time. Thank you, Ariel.
Thank you very much.